In this video, let's talk about insecure data storage. Finding out insecure data storage vulnerabilities on an application requires you to have a jailbroken device. It is also possible for us to view the application's local storage on a non-jailbroken device using the setup that we have. So I'm going to demonstrate insecure data storage vulnerabilities both on a non-jailbroken device as well as on a jailbroken device. Okay, so now let's get started. Mobile apps often store data on client side. If you remember, when we started the application for the first time, it was telling us that the server is not configured. How is it possible for the application to determine that the server is not yet configured? It is making some client-side check to see if a specific file exists. If the server is already configured, the file exists and the app will not show us the message again. Right, so that means the app is storing something on the client side to do some tasks. Similarly, some developers make a mistake of storing sensitive data on the client side. While it is required for us to have jailbroken device to be able to access this data, it is not a best practice to save sensitive data in clear text on the local storage. Right? So that's what exactly we are going to see in the vulnerable application in this video. So these are the few ways that apps use to store local data: plist files, NS user defaults, SQLite databases, core data, and keychain. Plist file is something like an XML file that can be used to store key value pairs. NS user defaults is also something similar. And SQLite databases are lightweight databases that can be used to store and retrieve data. And core data is also something like SQLite databases. And keychain is Apple's recommended way of storing sensitive data on the device. In this course, we are not going to go through every single type. We will cover some of these based on the application's functionalities. So the vulnerable application that we are going to use may store some sensitive data on the client side. So let's go ahead and explore if it is storing any data on the client side using any of these techniques. First, we are going to do it on a jailbroken device, and after that we are going to use a non-jailbroken device. Okay, so let's switch to a terminal and let me quickly find out the IP address of this device. This is 102 SSH root at 192.168.0.102, and let's enter the password. And now let's launch the application, and let's first log in using secure store account, and let's tap sign in. Now let's tap on view profile once again, just to make sure that we are browsing through the entire application. Now let's enter some test data into this application. This is like a secret vault application. We can basically store some bank account numbers into this app, and when we want to view the information, we can retrieve that. So let's see how this app is storing all this data. Bank name, let me enter test. Account number 1234567. There are no restrictions on the client side, so you can basically enter anything, but there are some basic validations, like if you don't enter every field, it is going to throw an error. Similarly, if you try to retrieve something without entering an email ID, it will once again throw an error. Right? The branch name test and email ID test@test.com. And let's tap on save bank details. As you can see, your data has been saved successfully. Now test@test.com, and let's tap on show bank details. As you can see, it is retrieving whatever the data that we have entered. That's fine. Now let's go ahead and explore the local file system of this app on the jailbroken device. As I mentioned earlier, the data directory is inside /var mobile uppercase C containers data application. And inside this, we will have some UUIDs. Every time you install an application, it gets a new UUID by the device. Now, we don't know the device UUID yet, so let's just navigate to this directory first, and we are going to use some Linux foo to find out the directory of this application. Let's type find dash type, and let's specify that it's a directory, and let's specify the name of the directory. This has to be the bundle identifier of this app, so it has to be cst.securestore v1. So this is the bundle identifier of Secure Store v1 application. So let's hit enter. As you can see, it has identified the bundle identifier, and this is the location of our application. So let's navigate to this and let's type ls. There are 4 different directories here. So let's navigate to documents, and there are some interesting files here. One is bankdetails.db and another one is config.plist, firstrun.plist, and userdetails.plist. Since we don't need this mobile screen anymore, let me just expand it here. Now, what we are interested in is, we are interested in all of them. So let's go through one by one. I will begin with this firstrun.plist. Let me copy this and type cat and paste the file name. And if you look at this, it says is first run set to false. So that means the app is already run. Okay, so this file is not so interesting. So let's go to the next one. Let's go to config.plist. I'm going to open config.plist using cat. And if you look at this plist file has the server IP address. This is the server that we have configured. So once again, not so interesting. Anyway, we can see this IP address in Burp Suite. Now let's go back and let's check out the next file, which is userdetails.plist. Let's copy this and let's paste it. And look at that. It has an authentication token of a specific user, and the username of that user is Secure Store, and it says he is logged in. Now, it is very common in bug bounty programs that if you find something like this on client side, they will probably reject it. Now, what we have to do is we will have to turn this local storage vulnerability into something more valuable. So we are going to see how we can turn this into an authorization vulnerability later in this course. But for now, remember, this is how you can explore the local data storage to find out sensitive data that is stored by the app. Now let's move on. And there is one more file that is of our interest, which is bankdetails.db. Let's check what kind of file it is by typing file space bankdetails.db. As you can see, this is a SQLite file. So we need to have a SQLite client like this. Looks like we don't have any SQLite client on this device. That's fine. We can just pull this file out and we can explore it on the local machine. So what I'm going to do is I'm going to desktop, iOS pen testing, and here I'm going to make a new directory called local storage, and I'm navigating there. And here I'm going to download that using SFTP 192.168.0.102, and let's enter the password, and let's provide the path of this particular file, and let's type get /bankdetails.db. As you can see, the file has been pulled out. Now let's quit. And if you see the local storage folder, we do have a new file called bankdetails.db. Now let's once again run file command against it just to confirm that the file is intact. Now let's use a SQLite command line client to connect to this and explore the database. Okay, we have connected to the database. Now let's type .tables, There you go. We can see the table names. Inside this, we do have a table called bank details. So let's run some basic SQL query to see if there is anything interesting in this table. So select star from bank details. Looks like there is something wrong here. There is no from is missing there. And there you go. This is what we have entered into the application. This application is meant to be a secret vault. It has to keep the secrets secret, but it is exposing everything in clear text because the data that is entered into the app is being stored on the disk in clear text, right? So this is how we can identify local storage vulnerabilities in a jailbroken device. In the next video, we are going to see how to explore local data storage using a non-jailbroken device.